So that's what we did last week, and because we had one hypothesis about a population and we took one sample from that population, this chapter compares two populations. So what we'll be comparing is something like this. Is mu1 equal to mu2? That would be the hypothesis. And so if we're comparing one population mean to another population mean, then we have to take two samples, one from population 1 and one from population 2. And those samples need not be the same size. You can have a varying amount of size between the two population sizes. And so if this is the test, is mu1 equal to mu2, what would be the alternate? mu1 not equal to mu2. And so if you look at the handout that we had last week, we see that the three columns in the lower half of the handout, two populations, two samples, we see the different kinds of setups. mu1 is equal to mu2. The alternate would be mu1 is not equal to mu2. If the setup were mu1 is less than or equal to mu2, then the alternate would be mu1 is greater than mu2. Or if we had mu1 is greater than or equal to mu2, the alternate would be mu1 is less than mu2. So that's the arrangements of the hypothesis testing that we're going to be doing in this class. Any one of those three types, and similar for pi 1 and pi 2. Okay, so that's the first step in the hypothesis test is state the null and state the alternate. Okay, so similarly here, it'll be one of those three. The second step in the hypothesis test is what? State the level of significance. And we get to choose the level of significance, 0.01, 0.05, 0.10. So in any example or at any test or at any time, if you do a hypothesis test out in the world, you'll be able to select 0.01 level of significance, a 0.05 level of significance, or a 0.10 level of significance. What's the third step in the hypothesis test? Take a sample. In this case, we have to take samples. We have to take a sample in population 1, and we have to take a sample in population 2. And when you take the samples, what do? You calculate the statistics that come from the sample. And so usually what comes from sample 1 is, you'll see things like this. In taking a sample, n sub 1, what's little n equal to? Sample size. So this would be the sample size of sample 1. Let's say it's 30. Now, like I said, you don't have to have the same number of observations in each sample size, so this could be a sample size of 60. Okay, so sample sizes could be different. Another thing that will come from the sample is x bar 1. What's x bar 1?
Sample mean.
It's the sample mean from sample 1. And this will be the sample mean from sample 2. So that will be a statistic that you'll have to calculate, or you'll have to be given. Now, you may at some time know what sigma sub 1 is equal to, and what sigma sub 2 is equal to. What's sigma stand for? Sigma stands for the population standard deviation. So this would be the population standard deviation of population 1. This would be the standard deviation of population 2. So actually at the beginning, what you should do is you should label one of your populations 1 and the other population number 2, so that when you go through and calculate N1 and N2, you do it correctly. So whatever population 1 is, we're going to do an example in a minute about Northeastern students versus BU students. Okay, and so Northeastern students will be sample 1 of population 1, and BU students will be population 2. But you should designate which one is population 1 and which one is population 2 before you do the study, so that when you do N1 and N2, you don't get them confused. And you do sigma 1 and sigma 2. Make sure you designate them correctly. Or sometimes if you don't know, or most of the time when you don't know sigma 1 and sigma 2, you have to estimate the population standard deviation through the sample standard deviation. So you have to calculate the sample standard deviation of population 1, sample standard deviation of population 2. So these are the these are the statistics that come from a sample when you're testing mu1 versus mu2. And so, what's the fourth step in the hypothesis test? Determine the test statistic. And so, how do you determine the test statistic? Take out the decision tree. What's the first question in the decision tree? Go through it. Find out if you end up in the T box or the Z box. That will dictate whether or not you have a t-test statistic or a z-test statistic. And so, if you have a t-test statistic and you have two populations that you're comparing, the second page of last week's handout showed you all the different test statistics that one would use in this class. And so what you would see here is that you wouldn't be using one population, one sample, you'd be using two unrelated populations, two samples. And so if it's a T or a Z, we have how many choices here on the handout? There are 4 choices. 2 of them are Z's and 2 of them are T's. The bottom one to the far right is a Z, but that's going to be dealing with P sub 1 and P sub 2. And what are P sub 1 and P sub 2? P sub 1 and P sub 2 are the sample proportions. So that's not going to be the test statistic used here because we're looking at mu1 and mu2. So you're left with 2 T's and 1 Z. And so let's say you knew sigma 1 and sigma 2. Let's say these were known. Which would be the test statistic? It would be the test statistic that uses sigma 1 and sigma 2. And it's a Z distribution. Because if you go through the decision tree, one of the questions is, do you know sigma? And if the answer is yes, you end up in the Z box. And so that's why you have this Z as a test statistic. Now, if you end up in the T box, there are 2 choices for T. And so if you look to the right of the first one, what does it say? It says assume equal variances. So in order to use that T, you have to assume equal variances. And so what will happen is in the question, you'll have to read it to see if it says assume equal variances. And if it says assume equal variances, you use that test statistic. If it doesn't say anything, then you use the other test statistic, where it says assume unequal variances, or we don't really know anything about the variances. And so you would use that test statistic.
So that would be unknown also?
Yeah. Okay? All right, so those are the test statistics. And what's the 5th step in the hypothesis test? Formulate the decision rule. The decision rule is the same as it was last week. The only difference here is going to be that if you have a t distribution, question is going to be how many degrees of freedom are there? And so if you go over to the page before, where it has the different test statistics, if you see the T in the top half, under 2 unrelated populations, 2 samples, see where it says T subscript N1 plus N2 minus 2? Everybody see that? Mm-hmm. Okay, if you have that T, that subscript is degrees of freedom. N1 plus N2 minus 2. If you have the other T, what does it say about degrees of freedom? It says, go to page 388 and look at how it's calculated in 11-8, degrees of freedom for unequal variance test. Okay? Most of the time in this class we're going to assume equal variances, so I'm not too many times am I going to ask you to calculate those degrees of freedom. I might once. Okay, so remember that if you have a decision rule with a t-distribution and you're comparing 2 population means, then degrees of freedom are a function of the T test statistic. Okay. All right, so with that, what we'll do is we'll run a test. Anybody have any questions as to the different steps that we're going to use here for testing hypothesis for two population means? All right, so let me see. I'll try to make some of these numbers work out. I know what we'll do. So the first one I don't have to. No, I don't have to do that either. Actually, I can just make one up as I go along. Because, we're going to test is average NU annual income after, well, let's see, average NU student annual income after graduation greater than BU student annual income after graduation. So that's the test. Is Northeastern University student graduate income more than BU student annual income after graduation? So if we were to write this relative to is mu1 relative to mu2, what would we be saying here? If let's say 1 is NU and 2 is BU, what would we be saying here for the test? Is N is mu sub 1, which is NU, so we can put a little NU in here actually, greater than N sub 2 BU. Is Northeastern income greater than BU? Because that's what the test is, because they're looking for greater than. Okay? And so, if this is what the test is, what's the alternative to this? Mu sub 1 less than or equal to mu sub 2. Correct? Okay, so for hypothesis testing purposes, which one of these is H sub 0? That's the bottom one. Okay, so it's mu sub 1 less than or equal to mu sub 2 versus mu sub 1 greater than mu sub 2. And so what we would do down here is we could also list this, say NU down here, this is a BU, this is an NU, and this is a BU. You don't have to list these subscripts, you should list it up here at the beginning, and that's what I want you to do. You have to tell me which one is which when you do the test. If you just give me a 1 and a 2, it's difficult for me to understand, if you understand, how to do the test. And so make sure that you designate which one is population 1 and which one is population 2. Okay? What's the second step in the hypothesis test? Level of significance. And let's say it's 0.05. Okay, so we decided that the level of significance is 0.05. What's the third step in the hypothesis test? The third step is to take a sample. All right? So let's say that N sub 1 is equal to 100. Now what's 1 again? That's Northeastern. Okay, we took 100 Northeastern students and we'll say N sub 2 is equal to 144. That's BU. With N sub 1, we have to get a sample mean. So we get the 100 observations, and we'll say that the sample mean was 54,900. And we'll say that X sub 2, X bar sub 2 is equal to 52,000. And let's say we knew sigma for both of these. So let's say we knew sigma 1 was equal to 5 grand, and sigma 2 was equal to 3 grand. All right, so let's say you're given that. What's the fourth step in the hypothesis test? It's the test statistic. So, how do you determine if it's a T or a Z?
Put in a chart.
You take out the decision tree, and so what's the first question?
Is it normal?
Is the population normal? And so, we saying anything here about the population normals? Yeah, normals. Anything about the population being normal?
No.
No, so where do you go? Left? What's the next question?
It's N 30 or more.
Is N 30 or more
And
in both of these? And
sigma known.
is sigma known?
Yes.
And the answer is yes, and so what do you have?
Z.
A Z. So you have a Z, and so what you do is you take the Z, and you just write the formula down. So, not remembering what it is, that's why I have open book tests, because, like I say, if I don't remember it, they don't have to remember it. So what do we have? It says x bar 1 minus x bar 2, whoops, over the square root of sigma sub 1 squared divided by n sub 1 plus sigma sub 2 squared over n sub 2. And so, what do we do next? Just plug in the numbers. And so what do we have? We have 54,900 minus 52,000 divided by the square root of sigma 1 is 5,000. See, that's why I say you got to make sure now you know what's 1 and 2, because what you're going to do is you're going to take the 5,000 and divide it by 100. Whereas if you took the 5,000 and divided by the 144, it would be wrong. Okay, so it's 5,000, no, it's 5,000 squared over 100 plus 3,000 squared over 144. And so what is Z? I can do the numerator, somebody will do the denominator for me. So the numerator is 2,900 divided by this. So what is this? It's 5,000 squared divided by 100 plus 3,000 squared divided by 144. Add those two together. Take the square root.
559.
559?
Yep.
That's the denominator.
Correct.
And so therefore, what's 2,900 divided by 559?
5.18.
5.18.
Yeah.
What's 5.18? It is the test statistic.
Do you want us going out 4 places on this, or
Well,
does it matter?
usually in the test statistic, we only go out 2.
Okay.
And the reason is because the Z table only
Only
goes
goes
out
to
2, and the T table only goes out, the T
Goes out
table goes
3.
out 2 or 3.
Yeah.
2's fine on the test statistic. 2's fine on the test statistic. And so, then what's the fifth step in the hypothesis test? Is to formulate the decision rule. And so, what kind of a distribution was this? Was this a Z or a T distribution?
See.
This is Z. Is this a 1 or a 2-tailed test?
2.
This is a, how many tails? If this is the setup over here, less than or equal to versus greater than?
No,
Is
it's
this a
one-
1 or a 2-tailed test?
1 tail.
This is a 1-tailed test. Which region has the rejection region? Is it on the left or the right?
To the right.
It's on the right. So this is accept HO. This is reject HO. accept H1. Area in the tail here is alpha, so it's 0.05. Now remember, this is a Z distribution. And so if the area in the tail is 0.05, how do you look up the Z on the table? Well, you have to find this first, 0.4500, because 0.4500 plus 0.05 is equal to 0.50. Okay, so when you look up 0.4500, what is the critical value?
4.65.
If you look it up, 0.4500, 1.65, 1.64, 1.65. So either one is all right, so we'll put a 1.65 here, or 1.64, or 1.645. It's fine. And so this is the decision rule. And what does this decision rule say? It says if the test statistic Z is less than plus 1.65, then what do? We accept HO. If not, reject HO and accept H1. And then,
Can I ask a question?
yep,
Is it correct if we also, instead of saying accept HO if it's less than 1.65, is it correct just to say if it's more than 1.65, reject HO? Does either one matter?
technically, in statistics, the test is always about HO. Always about HO.
So saying reject HO is, that would be fine to
Is the technical
say?
way to say it. No,
Okay.
well, actually what happens is what you're supposed to say is you set up the null and the alternate.
Mm-hmm.
And so the test is always about HO. And so if you accept HO, you go to HO and say, accept H1.
Mm-hmm.
That's it.
So that's fine to say it that way.
Yep. Versus what?
Well, when you had said it first, you said, if it's less than 1.65, accept HO, and if it's not, reject HO. So I would just go right to.
Yeah, but no, it says, wait a minute. Yeah, it says if the test
Yeah.
statistic is
Accept
less than,
HO.
then accept HO.
Yeah.
If not, reject HO
Yeah.
and accept H1.
Yeah, yeah.
Yeah. All right, so that's what we're doing. We'll find out that
Yeah.
the 5.1A is to the right, so what do? We did what this says, reject HO and accept H1, and then you go back, you reject HO,
Yep.
you accept H1, and that's whatever it is.
I was just looking at the phrasing of it, if you can, because what I've been doing is just, if it's in the reject region, I just go right to reject HO. Do you know what I mean?
No, other than if you find it over here
Uh-huh.
at 3, and you say reject HO.
Rather than saying accept H1.
Oh, well, you
Do you know what I'm
should.
saying?
Well, it depends. It depends. The first time around, when somebody's submitting something to me, I want to make sure they know
They
what
understand
they're
what we're doing,
And
okay.
so if you say reject HO,
Uh-huh.
okay. Now, it depends on how you set up HO, because students always don't set HO and H1 up the way I'd like to have it set up, which is this way. So it's important that you put down the first time around HO and H1 correctly. Because if all you're going to say is reject HO and accept H1, okay, I go back here to see what it is. But now remember, you have to actually answer the question up here about the claim or whatever it is. And so over here, it would say reject HO, accept H1. And so what is H1? H1 is U sub 1 is what? Greater than U sub 2, correct?
Mm-hmm.
So,
And use annual income as more than.
right,
Yeah.
right. So average annual income is greater than average BU income. at 0.05 level of significance. I'm gonna put a little student in here, because that's what we looked at, is a BU student. And then I think it also says like after graduation. So you put that in here too, after graduation. After graduation. And this would also be after graduation. Okay? So what you want to do is you want to answer whatever's being tested. And so therefore, sometimes students don't tell me what's being tested. They just say, reject H or accept H1. I have to go back over here. Sometimes I don't see it. And so I can't follow what your answer is relative to what the question asks. Like I said, I mean, you could do this all wrong and then just say yes. And what is the true answer, statistically speaking? The answer is yes, but you gotta show me that you understand what each of these steps mean, how you go from step one, how to calculate the test statistic, what the decision rule is, how you make your decisions, etc. Because I won't accept yes, even though it's right, and I want to make sure that this step is correct, this step is right, the test statistic, the decision rule is okay, and then you make the right decision, but you have to tell me yes or no at the end of it all. Okay? Anybody have any questions then on 2 sample tests of hypotheses?
Unrelated.
These are unrelated populations. Meaning, is there any relationship between BU graduates and NU graduates? They seem like 2 unrelated populations. Okay? So this test is for unrelated populations, because now what we're going to do is we're going to go to related populations. Populations that are dependent upon something common. That's the last half of this chapter. So these are tests for unrelated populations. Okay, all right, you have a question?
Yeah, my only question was, like, how do you figure out if it's gonna be a one-tail or two-tail?
Do you have the decision tree? I'm sorry, do you have the handout? You have that handout right there? Yeah. You see that first page? Okay, so if it says, it starts out, the first page is, it says HO U is equal to some number, and then H1 was mu is not equal to some number, correct? And if you go further down, if it's 2 populations, it says HO mu1 is equal to mu2, and then it says H1 mu1 is not equal to mu2. See those are in a line or in a column?
Yeah.
Okay, and I think up here there's an A, I think. Is there an A up there?
Yeah.
Okay. And then you see the B and the C? You see the set up there?
Yep.
Okay, so you go to the last page of the handout, and it says formulating the decision rule. See that? Okay? And so if it says, here it says if A, okay, and then it looks like this.
Oh, okay.
Looks like this, right? It's a 2-tailed test. You see that? If it's well, let's say it was less than or equal to, greater than or equal to versus less than. This is, I don't know if this is B or C. How is this one set up? Less than, greater than or equal to versus less than. Is that set up like C on the first page?
That's right. Yeah, that's C.
Like C? Okay, so and then if you look at C on the last page, the rejection, the rejection region is on the left. Right?
Yep.
Is that correct? Yeah, so that's how you do it. That's how you can tell if it's a 1 or a 2-tailed test. And intuitively, the reason why this is a 2-tailed test is because equal to is the test or the hypothesis, and not equal to is the alternate. So for not equal to, it could be less than or greater than, because both of those are not equal to, less than or greater than. So that's why it's a two-tailed test. Whereas over here, it's greater than or equal to, but the alternative is just a one decision, meaning it has to be less than. So that's why the rejection region is over on the left, and it's a one-tailed test. Okay, because there's two options here, or two alternatives, whereas there's only one alternative here. So that makes it a one versus a two-tailed test. Okay?
All right, thank you.
Right? Okay.